Hello, in this video we are going to review some math functions and discuss randomness in computers. This video assumes you have already reviewed the videos on variables and assignments. So let's get started. I've created a program here. I call it random number. One thing I want to point out is this form of writing our main function. Remember, all C++ programs must have a main function, and only one main function. The main function is always the starting point when we run a program. Normally, we have written our main functions with just an open paren and a closed paren, with nothing in between. This is an alternate format, and we will get into this later in the semester, and homework 5 will use this form. So I've created some integers, op1, and I've initialized it to 17, also op2 and initialized it to 5, result, which will store an integer, and here I have a double, and it's a double op1, so we can tell the difference. And we have double op2. I've also initialized these. And I have a double result. So on line 21, you can see I'm dividing op1 by op2. Does anyone have a guess as to what the result will be? Obviously, there must be some difference because I'm doing the exact same thing here on line 24, but I'm storing the answer in a double. Remember, doubles are floating point numbers. So let's run this program. But first, you will notice I have a red dot here. This is called a breakpoint. So when I debug a program, the compiler will start at the main program and start executing these commands in sequence. So it'll execute the statement on line 16, then 17, 18, 19, 20 is a blank, there's nothing to do, 21, 22. So when it gets down to line 26, before executing line 26, we will stop. So let's see that happen. So if I start debugging, which is also the F5 key, and you'll notice the window, the black window, showed for a moment. It is down here in the taskbar. If I open that up, I have op1 divided by op2. Remember, op2 is 5. 5 goes into 17 3 times. So, what does that tell you about this? That is integer arithmetic. Okay, we have 17 divided by 5 is 3 with a remainder of 2. But we also have op1 divided by op2. I'm putting that into a double. Why is that a 3? Because we're still doing integer arithmetic here. Both numerator and the denominator are integers. So that's integer arithmetic. And we're putting that into a double. And we could see, if I hover over here, that's telling me what is currently in double result. So op1 divided by op2 is 3. Op1 is 17, op2 is 5. Here op1 is 17, 2 is 5, and the result is 3. Whenever we have integers in our numerator and denominator, we have integer arithmetic. If we wanted to force this to be double, we can do that. Let's break out of this program. You see the arrow here? That means we're still, quote, running. I have to stop running the program. So I'm going to stop running the program, and I hit Shift F5. One way you can do this is if you multiply the numerator or the denominator by 1.0, I will force the result to be double. So let's run this again. I'm going to hit F5. I'm going to look at my results. We can see double result here is 3.399. And we can confirm that due to rounding I got 3.4. The integer result is still 3. Now if there is integer arithmetic, we must be able to get the remainder somehow. And we can with the percent key. So op1 percent op2. That's modulus arithmetic. We call that mod. So op1 mod 2. I want the remainder when I divide 17 by 5. So I'm going to continue right now, which means the program will execute until it sees next breakpoint. And what is in result now? Result is 2. So if we look here, the integer result is 3, so 17 divided by 5 is 3, with a remainder of 2. Now, let's get into random numbers. So I've modified the program here. I need some includes. I need to include cstdlib. That enables us to use the randomize functions. And I've included ctime. That enables us to use time. We'll use ctime shortly. But right now, if you look down on line 32, here's a random number generator. So we have random or randomize, and all we do is type in the command rand open paren close paren and the number we're going to divide. Remember, this is modulo. I want to simulate the numbers on a die. So first off, I've created a constant. Remember, a constant is something that is constant. It never changes throughout the program. You have to declare its type. So the type of this variable is integer. The variable name is sides. Constants are always in uppercase. So I will change this to sides. Okay, so I am simulating the toss of a die. So here's 3. Let's just add 3 more just to see this. Okay, I'm going to press F5 now, and we will see the results. So my results are 554454. That could be random, might not be, but let's try running this program again and see what our results are. So I'm pressing Shift F5. Now I'm going to run it again. Let's look at the result. 554454. Let's try that one more time. Shift F5. Let's Shift F5. F5 again. And look at the results. 554454. It looks like the results are the same every time we run this, which in fact they are. There is no such thing as randomness in computers. Computers do the same thing over and over again. They are very good at that. When we use this randomize function, we are doing the same thing over and over again every time we run it. So how can we create a pseudo random number? Pseudo meaning it looks like a random number even though the computer is doing the same thing over and over. So let's modify the program a little. We can do that by using the time functions. Remember the include I had above? I'm going to create a seed. The seed is set by the command srand, and I want the seed to be different every time I run this program. If I did not make it different every time I ran the program, the randomness would always look the same. But what I'm doing here, I'm seeding the randomness by taking the current time, and passing it as 0, always returns the current time. The current time is always going forward. It will never repeat. Therefore, I will always get a different seed and therefore different numbers in my randomness. Let's press F5 again and see what we get. So we had 315024. Looks like that's pretty random, doesn't it? But 0 is not really a valid die throw. When we have a number and we take it mod 6, that means we will have a remainder of 0 through 5, correct? If we want to include the numbers 1 through 6, we simply have to modify our program. I will press Control Shift F5 here, and let's add +1 here. Now by adding 1, I am guaranteeing to have a number between 1 and 6. Let's run this program again, and we'll look at our results. And we start 243652. So let's remember that. 243652. I'm going to run the program again to see how random it is. Okay, remember last time was 243652. Now we got 426224. Alright, that's looking pretty random now. Let's do it one more time. So the second set of numbers 426224. We will run one more time, and we got our results, and we have 635522, which is nothing like the first two executions. So this is randomness. Basically, you want to set a seed before you randomize. Then you call the randomize function, which is rand, and that gives you a random number. But I want the random number to be within the integers 1 through 6. So I modded that random number by a number, in this case 6, because there's 6 integers to a die, and I add 1 to it. So I'm guaranteed to have a number from 1 to 6. This concludes the video on the review of math and randomness.